So hi everybody. As you know, every time we speak in English, due to a couple of non-Bulgarians in our country, which is they're welcome, right? So thanks for coming. The less people are coming with the price going down, so that's normal. In a bear market, you know, the situation is like that. So basically, this is Crypto Meetup number 33. 33 months we've been following Bitcoin and blockchain in the whole space, and every time we try to present some new topic and something interesting. On a bear market, we try to speak more about the technology and why is it important. On a bull market, we, I don't know, bring some people to tell you how great it is to invest, but yeah, that's life. So what is going to be today's day about? We're going to cover two topics. There are two presentations by two great speakers. One is going to be blockchain, what is it for? And actually a couple of use cases by somebody who've been in that industry for a while. And then Ethereum scaling solutions by NewCryptoBlock. There will be consecutive presentation. Vlad actually asked me to do some sort of a wrap-up and opinion of why the market is going down. So I decided to do that. But basically, I also call that slide, let's think out loud. So these are all speculations. These are all stuff that basically I came up with it today, just thinking about it, why it could be wrong. But I actually urge you to, whoever wants to add reasons and add things out of their knowledge to speak about it as well. Obviously, you know, we're in a market where, you know, it's what is like 10 years old market now. Probably there are people who invested when Bitcoin and Ethereum were like cents and dollars and tens of dollars, and some of these people cashed out. I personally cashed out at whatever, like 25, 30, 40x, and I missed a lot of opportunity. Basically, I bought Bitcoin at whatever, like 200 and cashed out at 5,000, which is really good, but I didn't cash out at 20,000. So, you know, many people cashing out, so this is kind of creating influx of supply. Quite a few sophisticated investors are really making sure that their chips are properly distributed because, you know, as you know, this space is kind of ugly sometimes. What we see a lot is that smart investment opportunities with these very good ICOs that are actually top projects are becoming more and more restricted. Back in the days, everybody could have participated in any ICO. Today, most of these top projects are like, you know, saved for like funds and the early adopters, the Valley guys. So it's really going back to these restricted scenarios of, you know, only the insiders can be part of the insider opportunities. What I believe is also that many ICO didn't live up to the promise. And many ICO has been driven the demand of this cryptocurrency. Bobby, who probably you guys know from blockchain, what was his fund? Blockchain Capital. He didn't call it like that. Anyways, but he had a really nice drawing that basically, in order for you to invest in any crypto asset, you first go via Bitcoin or Ethereum, and then obviously the price of these two raises up first, and wherever everything else goes down, like sooner or later the other two also fuck up. I see that there is a lot of this chain sentiment. This year, no, last year was really crazy because the amount of, basically the speed of growth was super fast. And everybody started speaking about it. Like maybe last year was the year where this thing became sort of mass phenomena. Everybody started speaking about it. We used to have these videos of Giorgiano kind of speaking about stuff. That's not good, but you know, everybody, like your friends, hey, let's go and invest in this, let's go invest in this. There are ugly situations, people, you know, mortgaged apartments and things. This is fast sentiment, fast positive sentiment. But when things start going down a lot, this is even faster negative sentiment. So probably now people who got hurt are like really, you know, back in the days, these sort of crazy schemes, and it's really like change sentiment, I believe. I don't think that Ethereum really became part of the network effect. Ethereum obviously is a platform where this ICO became part of, but Ether itself is not part of the network effect. Like people bought Ether to buy the ICOs, but Ether is not part of it. And many of you can have opinions on that, but I just didn't see that this became part of the whole ecosystem in a positive way. It might become, there are issues of scaling. We spoke when these CryptoKitties kind of blew the Ethereum network. We'll see. I put the over-the-counter, basically is the term from medicine, that people kind of had the chance to buy and sell a lot. Back in the days here, there were like crypto, BG, and all these sites you can really buy fast. Like this was all over the world. You could have bought all these assets very easily. Nowadays, not really. Like we know all these banks that they become restricted. There are more and more of these stories that people are not allowing you to buy via the banks. Exchanges are kind of increasing the KYCs all the time. And these are discussions like this is becoming much more of a restricted asset. Obviously, regulations. Is it the securities, the utility, the stupid topic? SEC is playing really tough. Ivan mentioned something today that SEC is really like going against it. Obviously, there are good things happening as well, but like sort of this is the general sentiment. I think China is becoming restricted. You know, there is this Peter Thiel saying that crypto is libertarian and AI is communist and China is communist, so they are not really libertarian. And I think they are becoming more and more restricted. There are exchange clauses there and then a lot of these miners and stuff. I believe that the crypto wars are playing a bad game as well with these Bitcoin Cash, Bitcoin Prime, Bitcoin, whatever they call it. That's why I just put bit what the fuck C. I don't think the community is united, and I don't think that the whole crypto is in a stage where it kind of became a mass sort of utility, mass adopted thing. But already we see that basically each different direction is kind of preaching their own religion, which is bad. And if you guys want to say something, this is just some stuff that I wrote down today. But if you guys want to say something why the price is going down, or if you want to add something, please do. Otherwise, we'll just jump on the presentations. Whoever wants to add something, these are just random thoughts that I put today. Obviously, this doesn't cover the whole thing. Some of you are very good insiders, probably you know stuff that I don't. But generally, that's pretty much how the situation is, in my view. So yeah, if you don't want to add anything, maybe we can jump on the first presentation. So basically, yeah, every time we track, this is from each meetup, the price of Bitcoin and then Ether, and did how it goes. Like I think that Bitcoin probably is reaching some sort of a normalized position where it should be, but the Ether is really bad. Yeah, this is sort of, anyways. But yeah, and actually, this is again something that I mentioned. I think that it didn't become that much of an important part of its own ecosystem. People bought it to buy stuff, but then it wasn't important for the ecosystem itself. That's my personal view. So yeah, that's how it is. Ether is going really bad. Like this is less than, so yeah, so it was like a crazy up and down, and I don't know what's going to happen. So yeah, that's pretty much sort of a small analysis. These are the two presentations of today. I'll just load your presentation and you can start. Maybe before that you can introduce yourself or whatever. Thanks, guys.
Hello. Maybe you should have recorded attendance and then plotted to compare it to the price of Bitcoin. Yeah, I'm Bojo. I'm founder and CEO of LogSentinel, where we use important parts of blockchain technology in order to guarantee integrity of data of our customers. So I will be a little bit provocative. I'll say things that you'd probably not agree with, but bear with me. First, let's get into some terminology. I know it's boring, but we have to get that cleared because some things can mean many things and we don't necessarily agree on them. For example, blockchain, fun fact, it wasn't actually coined by Satoshi. The paper never mentions blockchains. It mentions chain of blocks, there's the word chain, there's the word block, but there is no blockchain in the original paper. It was coined somewhere, sometime after that, and it's not entirely certain when. So blockchain can mean many things. It can mean the distributed chain of blocks. It could mean just chain of blocks. Actually, what it is in implementation terms, it's a chain. It's a hash chain. It's a data structure called hash chain, and it happens to be the hashes of blocks. But these are implementation details. DOT is a distributed ledger technology. Now that's a more wide, encompassing term. It includes anything that is distributed and that is a ledger. And then there's cryptocurrency, which I don't have to explain here. They are very different from the underlying technology. They are obviously implemented by the use of blockchain, but they are not necessarily part of it. They sometimes are used to fuel, actually, the use of the network, which I think was the idea behind Ethereum. Not to use it as a cryptocurrency per se, but to use it as a way to kind of stimulate the use of the network, which is the supercomputer, the world computer. And then there's private and permissioned and public blockchains. These are things that are deployed in a corporate network or across multiple corporations. They can be visible to outsiders, or they can be entirely closed. They can have a single source of authority, or they can be a distributed source of authority among the multiple corporations. So there's really a very wide variety of things that we call blockchain or blockchain technology. What are the key strengths? It is immutable, but the important thing is it's provably immutable. You can prove to third parties that the data hasn't been modified, not just know that it's not been modified. It's also distributed in most cases. Now, given that we have so-called cloud blockchain, Microsoft Azure, for example, offers you to deploy, I think, Hyperledger on Azure. And how is that distributed? I don't know. But all of these things are called blockchain. It is the thing that we mostly understand on the blockchain is distributed, and that gives it the network effect, that gives it the resistance to tampering, etc., etc. It is trustless, and it is hyped. Now, it's not all roses, as we saw in the first presentation. It is expensive if it's public. So if you want to use it for something other than cryptocurrency exchanges, then you have to pay the price for a transaction if you want to store any data on it or perform a smart contract. And because of the volatility of the market, this also affects your software. And this is not acceptable for businesses because they don't like volatility, and then they don't want to pay such higher transaction costs for transactions. It's not scalable at the moment. The presentation after me will be discussing in details what is the way forward for scalability, and it will be very interesting. It's not mature, so there are still things to discuss about how should we implement this. Is this a bug? It's a general understanding in the market that the technology is not yet mature, and it has a long way to go. And maybe you'll see in the next presentation what is the way forward there. One thing that isn't mentioned often enough is that it's going to be very hard to support software that is relying on blockchain at the moment, because you kind of do some hacks to implement blockchain within the organization. You have to write, for example, smart contracts. Whether the smart contract language is easy to support, I think no. And then these things are very hard to test, very hard to go through the normal software development pipeline. So it's more of a hacky thing right now. But there are real use cases, right? I mean, when you type top use cases for blockchain, you get a lot of results. Some of them sound very interesting. There's e-voting, there's provenance for food safety, for example, in China, land registry in Georgia, real estate deals, waste management, advertisement exchanges, music royalties, any kind of thing that you can think of. There's probably a blockchain startup that's doing that. And that sounds promising, but what do these projects have in common? First, yes, they can be built using some sort of blockchain. Also, they don't need it in most cases. They benefit nothing from being distributed. They are often not actually distributed. They put some stuff in there, but you access them through a centralized application anyway. They try to ride the hype and the fear of missing out at the same time. So some corporations say, well, we should invest in blockchain because who knows what might happen. So let's do a project with that. It will be a pilot, it will be a proof of concept, but let's do that so that we don't miss out. And as I said in the previous slide, they will be very hard to support because we'll build something now, it will barely work. And then someone will have to support it for years if it goes to production, and that would be hard. Why the distributed bit is not flying, at least at the moment, with end users. It is flying with us, we are using it, but users don't care. Users mostly don't care that the thing is distributed, that there's no centralized control, because they just want to get the service. They want to get their ride, they want to get their hotel, they want to check their food, whether it comes from the right place, but whether that's distributed and there is no central place that can control it, they don't care too much. And anyway, as I said, you have a centralized place to access most of these. You go to a website, you download an app. If you want to ask the user to walk the extra mile and use a distributed naming service based on blockchain and a separate browser and all of that, it becomes a real usability hurdle, and nobody wants to go there. Private key management sucks. Now, I like cryptography. I like to use crypto for cryptography rather than cryptocurrencies, but that ship has already sailed. But private key management for end users is very bad. I mean, you obviously have all of these wallets, they manage that for you. You can print your memory keywords, you can store it in a safe, whatever. But still, you have to manage a private key that normally you wouldn't have to. And this is, again, an extra usability problem that I think hampers the adoption of blockchain. And the problem is, I think, that in some sense, it doesn't solve real-world problems. It is a very cool technology, fully distributed, no centralized control, but it doesn't solve, well, it solves some problems, obviously, some problems that rely on not being censored, but it doesn't solve many business problems. You say, what about cryptocurrency? And this is one quote from Twitter I got yesterday. Bitcoin combines the libertarians' two favorite things, property and not understanding economics. Now, that may be a bit harsh, but it's kind of a 21st century tulip mania. So we kind of project some value on something, in the case of the tulip mania on tulips, on tulip bulbs, and in this case on some digital records in a ledger. But what's the actual value? As we saw, it's dropping. So some people say that blockchain is the new internet, and I think it's not. It's not a 10% improvement over anything. You cannot get it and improve some business process or some existing problem, or even something that hasn't been solved now. You cannot solve it better 10 times. You could probably solve it twice better, but that's not enough to foster wide adoption. If something is a revolutionary, then it should be at least 10 times improvement. However, blockchain is really cool. I mean, I like the technology very much. I've read the original paper, I've read many papers. The cryptography is stunning. And it has very interesting and very useful and very applicable components. The first thing is temper-evident data structures. This is, I think, the most important thing that got popularized by blockchain. Temper-evident data structures are hash chains and Merkle trees. And they allow you to prove to third parties that, as I said, data has not been tampered with, has not been modified, without actually giving the data to the third party. Light nodes work using these kinds of proofs, and it is a very good approach to many actual real-world problems. The Byzantine fault tolerance is a wonderful thing. It has been obviously used before Bitcoin and before blockchain. It has more narrow application, but it's still a very, very good thing to get popular. Because what blockchain did is make all of these things popular. It's a shared database. So if we see blockchain as a shared database, only as a shared database between a number of businesses, then it has some very good real-world applications. And then there's the shared code execution, or so-called smart contracts. And on a recent conference, me and another panelist coined the following: smart contracts are neither smart nor contracts, but they are useful. I mean, they don't have the legal strength, and they have some issues with, for example, debugging or releasing new versions, but they are a good way for multiple participants to agree on something that should be executed in an event of something happening. And blockchain and its components can solve problems. And one of the things that it can solve is prove unmodifiability. The thing that I've already mentioned 2 times, you can prove to third parties that your documents, that your logs, that your data isn't modified. And we have currently a proof of concept with Raiffeisen Bank, where we have deployed our private implementation of blockchain data structures for the following use case. They have their internal logs on the core banking system. And sometimes, in some rare occasions, but still it happens, someone decides to sue them. And they go to court, and then the court wants them to present logs. And the court can say, well, you could have faked those logs and given to us something that benefits you in this case. Whereas if they use the temporary evident data structure, they can give the logs and prove to the court that they haven't modified them. And this is a very good thing for them. There's also the problem of internal lack of trust. You sometimes cannot trust the employees. Certainly you cannot trust all of your employees. You obviously trust them in general, but any one of them can perform some sort of crime, and in larger corporations that is in many cases true. Internal actors can modify data, and this is an important thing here is a general way forward, I think, to use the public shared ledgers as a place to anchor your internal data. You don't put anything, you don't put your data on the blockchain because it's expensive. If we all go there, it will just blow up and won't be able to handle anything. But you anchor your internal data to the public blockchain with some meaningless hash. You just push it there and it stays there. But it guarantees that your internal structures are intact. And we have a use case with the state e-government agency of Bulgaria, where all of the access to personal data, if someone tries to read your address, for example, it goes through a centralized component. And all of the logs of this access are stored with us. And that way we prevent any malicious actor within the public administration to actually clear their tracks, so that they want to abuse their access to your personal data. They get the data, and then they clear their tracks. Now, in many cases, people don't believe civil servants. They don't believe the administration. So in this way, we can guarantee that they haven't cleared their tracks. And this is kind of important. There's also the multi-stakeholder database. And this is the broader sort of corporate deployment of blockchain. You have multiple organizations that want to share some sort of data or execute some business logic on top of it. You can have for example, higher education diploma registers. There are multiple universities, all of them issue diplomas. Maybe they could have a shared database rather than a centralized database in the ministry. Maybe it's a good idea. It is practically a signed shared database between multiple stakeholders, and that is useful. That solves supply chain use cases, that solves trust use cases among, for example, suppliers. And in the case of car manufacturers, you can have a car manufacturer and you can have dealers. And then you can track each car. You don't have to have the centralized database in the car manufacturer. You can have it shared between the larger dealers at least, so that each car is actually tracked and you can know the mileage. When you buy a car, you can check where it has been, etc. So these are real problems that bits of the blockchain technology can solve. And speaking of which, this is actually a remastered Dilbert comic. It used to be about, I think, the cloud. And yeah. So Yeah. What color do you want it? I think mauve has the most RAM, so yeah, I mean, obviously the boss has no idea what blockchain is. He heard somewhere that it would be useful, so let's use it in our big corporation. And in that sense, I think we can say that blockchain is the new cloud because it enables digital transformation through buzzwords. Some pointy-haired boss has heard that blockchain is cool, that it can protect something in your organization. Then it goes to the engineers and says, do blockchain. And they say, well, it doesn't have to be necessarily blockchain, but if you can give us the budget, we can solve these problems that we've always had. For example, something is on paper, or some people are manually entering data, whereas it can be automated. And such projects, such blockchain projects across the world, usually have these components. They digitize processes, and this is very important. Because if you don't have digital processes, you don't have digital transformation, everything is inefficient, you lose money, etc. Yeah, you can put a blockchain stamp on it, but the most important thing is that these processes become digital. Where previously companies have exchanged documents by mail, they now use, for example, Hyperledger. And could they build that with existing technology, for example, some web service? They could, obviously. But the fact that they say, well, we have blockchain and now we have transformed our services is good enough for me. They use it to protect the integrity. Now, you don't need blockchain for that either. You can use regular electronic signatures, electronic timestamps, and this is good enough. It has legal effect in the European Union, so it's a good thing. But people learn that blockchain can protect the integrity of data, and so they say, well, let's protect the integrity of our data somehow. Let's call it blockchain, but it doesn't have to be. We had recently won an award on one hackathon in Austria, where the company had a problem with the certificates of their products, that some of their intermediate clients were modifying them. And they heard that blockchain could solve that problem. They made a hackathon. Now, you could solve that problem again without blockchain. You could use digital signatures, you could make a centralized system, but the fact that they wanted to solve that problem because they learned about blockchain is important. Another component of this project is to share a database with partners. Can you have two systems that exchange data through an enterprise service bus or a message queue? Obviously you can, but if blockchain is the thing that makes you go there in the first place, great. And another important aspect of this project is that people want to use familiar technologies. This is why Hyperledger is getting so much traction, because it allows you to work with something familiar and just interface with it. Remember all of these projects in the beginning that I said that don't need a blockchain? Yes, you could implement all of them without it, but some of them were made reality because someone in the management chain learned that there is blockchain and they could apply it to solve their problems. And that way, I want to conclude that blockchain is not a revolution. It is a very cool technological innovation, but it's not a revolution, but it can be the right tool for the job. It can be the right tool for many jobs, just not all of them. Thank you.
Let's take a round of questions if you want. Sure. Do we have one? You want a mic?
I don't need a mic. I wasn't prepared to ask a question, but because you didn't mention, I mean, it's definitely an improvement with the financial transactions. And I really like your presentation because it gives a more clear view. But don't you think that still it's improving in some ways? I mean, Swift is super old and it's taking a lot of time and costs a lot of money. And now people are having control of their assets, I mean their money in general, and can send them anywhere they want in a matter of seconds or minutes, depending on what chain they're using. Don't you think at least in this direction it's improvement 10 times? I can see it myself. I mean.
Well, have you bought anything with Bitcoin?
No, I don't spend my Bitcoins on.
Exactly. So it might be, we just never learned because of the speculative approach. And I think that there is Bank of Sweden, they plan to make a centralized digital currency, and maybe that's the way forward. They will do electronic payments, but it won't be decentralized because it has all of these issues of speculation, of volatility, etc., etc. By which I thank you again, and I have to run to my next thing.
I just liked, because at the beginning, with the internet, if you read the history, it was started with a couple of universities, the military, then a couple of private organizations got in, and it was basically a network to share stuff. Then the forums started kind of becoming email and all these kind of things. And I'm also thinking that to have a massive use case, mass adoption use case, you need sort of the right, population to start using it for them to do it, because now it's just speculation. So intuitively, don't you think that there is like 10x improvement somewhere in some specific set of participants that really could be 10x? That's the thing. Because I'm thinking out loud. I'm not thinking about, maybe you think something.
Could be. The thing is, we are 10 years in almost, and it's not obvious. I mean, when we take the World Wide Web, it was 91 or something that all the...
It started really early. It started like 70s and so on, so it was 20 years or so,
Yeah, but once we had the World Wide Web, which actually made it possible to have these web companies, they were there in 2 or 3 years, and they were huge. So maybe there is, maybe we're missing, maybe we need some slight tweak in the protocols. Maybe state channels would actually allow all these things to happen. I don't know right now.
Cool. Very nice. Thank you. Give a round of applause to Božo and So the next presentation is going to be about Ethereum scaling, which is a problem that I mentioned previously. And we can start right away. Let me just check your... Okay, good. Thanks, man.
Thank you. Okay, unfortunately, Božo ran away and will not be in a position to talk later. But in my presentation, I have a lot of references to what he was saying. And it was good that he's challenging all of us, and it's good for all of us to see what we can use now, blockchains, and what we cannot, and what we will be able to use it for the future. So how we came up with the idea of coming up here and talking to you, with you basically, about this scalability solution of Ethereum. 2 months ago, I talked to Vlad, and he was like, do you have an idea what we can talk about? And I said, yeah, we have an idea. It's not just an idea, it's just something that we learned the bad way. I mean, really, it was a pain in the ass for us for some time to find the right solution, how to implement blockchain into what we were building. Some of the guys are here. And so I decided to come here and tell you our story, in a sense that something that we could have figured out later, we figured out very, for some time. So that's me. I don't know, it's my picture. Yeah, it is. I'm co-founder of NewCryptoBlock. We are dealing and actually focusing on product builds and blockchain innovations. So we talked a lot about Ethereum is, and we all know what it is, but actually at the moment the throughput rate is about between 5 and 20 transactions per second. In order to get mass adoption, we need to get to the enterprise solutions, which means that we need to get to 100K transactions per second. So it's not even 10K, it's name it. So I go back 18 months ago as well to the 2017 ICO hype and the promises that were made for easy-to-use decentralized web that can be used from billions of users. But that eventually didn't happen, right? A lot of projects raised millions, actually billions. And what I heard, it's not a massive voice out there, right? But there were some voices, especially from the developers, research and developers, infrastructure developers saying, okay, you raised the millions, you're millionaires now, and you're waiting for us to give you the solution. So I disagree kind of that that's the case, because even in our case, what we did is that we were looking for solutions. We were contacting engineers, Tendermint. A guy from Novi Sad came here and we were talking, and we were looking really for our case. But that's kind of process. And then, as an answer, one of these guys, I saw that example from the history. In the 15th century, this guy, Jonas Gutenberg, who was a publisher and printer, introduced the printing press in Europe. And guess what? Only 60% of the population could read at that time, right? There was literacy. There were no bookstores. And it was only the Bible out there, right? People knew only God. But thanks God, he did not care, right? In the beginning of 2018, this guy, who we all know, as well mentioned that 2018 will be the year that major deployments will be done, especially in the scalability projects, and so that's the concerning sharding and plasma, but only a few came out. So our belief now is that 2019 will be really the year of the major deployments. So which are the types of scaling solutions? Božo talked a bit about anchoring, so let me dig and dive deeper, not that deep, into that. So on-chain solutions, any change applied to the root blockchains, that's the Ethereum blockchain, right? Like change of the block size, to name a few later. Then off-chain solutions, these are actually solutions that solve computational privacy or high transactional problems outside of the blockchain. So on-chain layer 1 solutions. We're referring to on-chain as layer 1 solutions. Increase the block size of the blocks, actually. Yeah, increase block size to increase transaction per second. That, I think, it was done in Bitcoin. Changing of the consensus. We're expecting for Casper. Later on, we'll see what is the latest news. Sharding. That's horizontal partitioning of the blockchain, and the layer 2 scaling solutions that are most and well-known and kind of teams are working on are state channels and side chains. So I'll be talking about Ethereum sharding, state channels, Raiden network, which is payment channel network, more general known as part of the state channels, and Plasma Cache. What is sharding? I'll be fast here. Sharding has been implemented first, and correct me if I'm wrong, by Google to split up their search database. And later on, or in parallel, it was implemented in major SQL and NoSQL databases. And actually what it presents is splitting the database in a few shards. And these shards actually are stored in separate computers, separate servers basically, so they can increase throughput rate. So you can imagine that sharding is being done on centralized databases. How we can do it in a decentralized blockchain. So that's how Vitalik presented the sharding. You can imagine distributing the different shards of Ethereum, and you can imagine them as islands. So within the islands, you can do whatever you do. You can transact accounts are within the different shardings. And the major problem is here. If they want to contact with each other, what's happening? And that's major one even now. I'll tell you why. In general, I mean, that's a representation, sharding. You have the global root, which is the root chain, and the shards. Each shard has its own life further on with the substates and states. That's how a shard looks like. The header and the transaction body. And shard header is, you have the shard ID, the previous state, the post state of the posting of the transactions, and the signatures which validate transactions. How does the blockchain look like? It's more or less the same, except that the transactions in the header we have the state root, which refers to the whole blockchain, and further on we have transaction group root, which is actually presents a set of groups which incorporate each group transactions for specific shards. So transactions as well, once deployed, they have their states, and in the end they have a receipt. Why do they have this receipt? Because that receipt is stored in a shared memory kind of thing, and that's how the different shards communicate with each other. So if you want to make a transaction from shard A to shard B, we're looking for the receipts for different accounts so that we can prove that something has happened in shard B as opposed to we want to make it in shard A. But that's a complex implementation, and it seems that that's the reason why sharding is not implemented now in blockchain. It cannot be implemented yet. Actually, the lead developer, Vlad Zamfir, has stated recently that they have coded the proof of concept, which they will deploy and start experimenting. Actually, a funny fact is that in DevCon 4, 2-3 weeks ago, they were referring to sharding, and actually, well, it's known that sharding is going to be part of Ethereum 2.0, and that includes Casper as a protocol and additional sharding. So what they came up with a suggestion for the name, and that's obviously a joke yet, but they were referring to that as Shasper. And these guys from Mango Research gave the roadmap, but you can see here, probably cannot read, it says states could still change, and up there estimates. So probably by 2021 we'll have proof of stake, but it might not happen. So, and what will happen with the current block Ethereum chain, and then what will happen, right? There are still answers to be given. So level 2 solutions are off-chain. Before we start talking about that, I just want to reiterate on the fact that the crypto-economic consensus defined in the root chain provides a hardcore kernel of certainty, right? And that certainty, unless something extreme happens, we can, like 51% attack, we can say for sure that the execution of transaction or the execution of a smart contract will happen as it is written will happen, right? And the insights of layer 2 solutions is that core certainty, and I think Božo mentioned that, is used as an anchor. He used the term anchor, right? Is used as an anchor for the layer 2 scaling solutions. So let's see how it how it is happening. State channels, you mentioned as well state channels. I like the definition of counterfactual white paper. Counterfactual is actually one of the solutions, actually one of the projects that are focused on generalized state channels, meaning that they want to build a framework which can be used by other projects to build their own state channels. So there are two things that I want to pay your attention on. In the definition, the general definition, state-modifying operations, that means that any change, any action that you want, activities that you want to implement off-chain, that could be either payment on the blockchain, or it can be change of state, or it can be change of a value whatsoever. And the other thing is that is happening between defined set of participants. So state channel is very important, needs to be defined and opened between a number which is defined of participants. It can be 2, 3, but if one exits, then the state channel as well dies. So let me give you the example with Alice and Bob. Imagine that Alice and Bob want to play tic-tac-toe game. That's in Bulgarian, how do we call it? Morski šach. And the naive way of doing is that every change in the state is going to be a new transaction on the blockchain, right? In the Ethereum blockchain. However, every transaction will cost some gas, right? And it will take some time. If we are lucky, between 10 and 50 seconds. If we are not, it can take minutes. So we are losing usability. And what can we do with state channels? Actually, Bob and Alice can enter into agreement in a smart contract. Imagine that they put 1 Ether, each one of them, and then all the activities can be taken off-chain. So every move of Alice is signed by her and countersigned by Bob. And vice versa. When Bob plays his turn, then he signs the transaction and Alice confirms that. So that goes till the end. And once, given that Alice is winning, she claims that she's winning on the smart contract, and eventually the settlement will be organized. The problem is if she wants to manipulate the result, what is happening? Actually, in the smart contract, we're implementing a waiting time during which Bob can submit his last transaction, and depending on which is latest, the smart contract will judge which of both will take the will be the winner. Will eventually take the winning stake. What we achieve through the state channel, instant finality, actions, transactions between both participants can happen within fraction of seconds. Lower cost, basically no cost in this case, and privacy. Everything that happens off-chain stays in off-chain. Only the final result is registered on the blockchain. Payment channels are part of the general of state channels, except that it comes down to process of exchange of value between the participants and the resulting change of the global on-chain balance after closing the channel. And real case scenario, imagine when you go in the casino, you give cash and take chips. With these chips, you go on the table and you play. Given that everyone agrees of the outcome of a single game, they will not sign your transaction, but silently, if they do not protest, that's as if they're signing this transaction, right? So if you want to go out, in most cases without these chips, but if you have any, you go on the counter and you exit the statement channel. Very much like that. Raiden network is a payment channel network. It is, we can again repeat all these things that we were discussing. It's an off-chain solution. It's very much mimicking the actions of Bitcoin's Lightning Network, and enables near instant, low-fee, scalable, and privacy-preserving payments without the need for global consensus. Except how that happens is through these balance proofs. So basically, up there is a smart contract. You enter into that smart contract, you get ERC20 tokens. So that's important. It's different. Is that it is ERC20 compliant network, and then you can get exchange value. Important thing here is that it's a bidirectional channel that is being opened, and once Bob sends tokens to Alice, he sends as well his balance proof, which is signed, and vice versa. Once Alice sends token to Bob, he sends his balance proof signed. And everyone in the channel has the balance proof of the other side. And when someone wants to exit the channel, then, for example, Alice initiates the close action. She sends the balance proof that she has received and is signed digitally from Bob. Then we have the waiting time, and Bob needs to submit Alice balance proof. And there are some activities. If he doesn't submit that, what's happening, how it's happening, the end, what is happening at the end is that the settlement, Alice received the tokens she owns, and Bob as well. But why we call it Raiden? We call it Raiden because actually, if Alice has an established channel with Bob, but if she wants to establish with Chris and Dave and whomever, that's an additional cost because it's an on-chain activities. Every channel starts with a smart contract, if you show, and with that smart contract, entering into a state channel, that means that they need to pay the gas for that action. So Raiden network provides a network, basically how they actually, what is their solution is they provide a network with established channels. So basically, Alice needs to enter in once into the payment channel. And from there on, through navigating through different nodes, she can access the other participant in the network, given that they have any state channel at the end of the day opened. So in this case, if Alice wants to say, send to Dave, let's say, some tokens, then what is happening is actually that she transfers that balance, which is hash locked, in order to prevent these participants to take something from that. And once it goes to Dave, Dave silently, secretly requests the key for that. Once he gets the key, he can unlock his tokens only if he shares that key with Chris, with C. And Chris can unlock his tokens for lending the channel only if he shares this key with Bob. That being said, the lending of the channels and ultimately the final goal of getting the tokens to Dave are happening only through this key. And actually, once they unlock it, they can redeem it on the on-chain, right? But they're so small that doesn't make sense immediately to be redeemed on the blockchain. And what's actually in Raiden network is happening is that they are accumulating lending their channels and the fees that they get for lending their channels. And when it comes time and get more big amount, they can redeem it back to the main chain. Some real case implementations or work that's being done. We're talking a lot about gaming, and it is not a surprise that Funfair, for example, in Horizon Games, into the gaming industry. I talked about counterfactual. And interesting implementation is Chain. That's an adult business, but at the end of the day, they're pioneering with state channel, right? So if we need to reiterate, state channel rely on availability within the channel. It's worth getting into a state channel if you will update. There will be many updates of the state over time. We need to have defined number of participants. State channels gives us strong privacy and instant finality. Short walkthrough through Plasma. Plasma is as well layer 2 solution, but it's a side chain. And it's rather, we can refer to that as a design pattern, which adds a layer of smart contracts on chain, and they communicate with the Plasma chain. That's actually how it may look like. The root chain, and on top we can have many chains, and actually that allows us exponentially increase the scalability. Look at that as a different chains, right? Levels. What we are going to be focusing on is more on the one level of chain, second chain, and that's, let's talk about Plasma Cash implementation. So Plasma Cash is a very interesting implementation. There are two teams actually who are implementing it, Omisego and Loom Network. For the case of this presentation, I will go through the Loom implementation, but actually you can see here the two teams working together on how they're implementing into their solutions. It was funny for me to see these guys called Georgios Konstantinos or something like that. He's based in Athens, and the whole team of Omisego. So how does that work? This is a simple architecture, but you can see the root chain and the Plasma chain, how they communicate with each other. And then we have the client, which again communicates with both chains. The specific case with Plasma chain is Plasma Cache of Loom is based on ERC-721 tokens, which are non-fungible tokens. If we want to have to give an example, that's the CryptoKitties. Let's mention it once again. The specific is that each token has specifics. They have the ID, they have the attributes, different attributes. If you have played CryptoKitties, I have not, but some of my guys of my office have done so. Every different cat has different attributes. They were breeding, they were, waiting for that to grow up and then sell it. It was crazy. And during that time, I was trying to distribute tokens to some of our clients. The three main events actually that I want to talk about is how we can deposit, how we can generate plasma coin actually, how we can deposit it to the Plasma chain, and then how we can spend it and how we can exit it. So let's see how depositing look like. It's not that complex, but actually what is happening in Loom is that they have two smart contracts on chain. One is ERC-721 smart contract, which generates the ERC-721 token. So once the ethers go into that contract, the token with the ID is generated, and then it's sent to the Plasma contract. That Plasma contract is generating the Plasma coin, which is based on a slot number. I mean, it's mapped in the map of Plasma contract to slot number, and then deposit event is emitted. On the other side, Plasma listens, Plasma chain, so the blockchain which is on top listens to this deposit event, and when it sees, generate the block. Basically, in the Plasma chain, there are two types of block: deposit block and regular block. Deposit block you have only one transaction, which is the Plasma coin transaction, and the other are regular transactions that are happening into the Plasma chain. What is Plasma chain? Plasma chain is a real blockchain, right? It can be anything, but in that case of Loom, it is using a proof of authority, basically the operator, which is Loom network, basically, is running and creating the blocks. I talked about the two types of blocks. And what you can do with the coins when you get them on the Plasma chain, you can spend them, meaning that you can transact them. And periodically, Plasma chain submits the Merkle tree to the root chain, so that we keep that bond with the root chain. Spending, just a few minutes, I'll not be boring you anymore. How spending is happening. You have the regular attributes of a transaction, but what is interesting is that if user one wants to send the user to a coin, then he needs to assemble the history. And based on that history has inclusion proof and exclusion proof. I will not go in details, but user 2 gets the history and validates the history of the coin only for the coin itself and not the whole history of the blockchain, and then the transaction is happening. There are a few events for the exit, but in general you have as well that time slot for which once someone wants to exit it, the chain generates exit event, and then every owner of a Plasma coin needs to listen to that exit event. Of course, that needs to be implemented in the application, which is on top, because we as individuals, we cannot listen constantly, right? Benefits of Plasma. It's, as I said, validation is happening on a individual coin and not on the blockchain itself. The downside is that the tokens is not recommended to be they need just to be bigger in value, because when they're redeemed, the transaction cost will be much bigger, and it's just not worth it. Conclusions. For me, conclusions, these are really the top implementations right now that are happening, and they're still in conceptual, most of them in conceptual phase. The outline actually from the DEFCON 4 is that there is an understanding of the different teams that they need to work together. And they need to come to the end of the researches and implementation of these solutions. So that's the promise for the start of 2019. More or less, that's for me. Thank you.
So thank you very much for the analogies that made it much easier to understand. But the one thing I don't understand is the plasma cash. Where's the underlying value come from? I mean, is it the amount of Ethereum you stake? Is it the Ethereum price? Where does the underlying? So if you and I
Yeah. That's right. There are different cases, right? There are operators like CryptoKitties that are operating ERC-721 tokens. And specifically in that case, Loom Network, they are building their solution based on that paradigm because they're into the gaming business. And actually what they're doing, if you have heard Crypto Zombies, that's one of their games they're playing with, right? They're building. And these tokens represent different attributes that you constantly go for and you collect. That idea is good for all type of collection, for example, which is very common and very, very good business in North America. So, but the option is that in ERC-721 contract, you can invest, you can put heaters, and you keep the token, and then all goes on.
Okay, so then the ERC-20 token wouldn't like literally, because your analogy was like cash in your pocket with zero number, and each one is different. So then in that instance, it would be more, if you and I are trading, maybe we're trading like a sword in the game, and we kind of decide the pricing, right? It wouldn't be like
that's a business logic that goes beyond the technology. That's part of the business case, which is on top the application, right? Web or mobile or whatever, and really the value within that network of, I think. I think we're done. Thank you.
So guys, this basically was the event today. As usual, we have the sponsors from Eternity, BitHope and LaunchCup with some beers. If you want to have a chat, go ahead, do it. And yeah, cheers for coming, and that was it. Thanks.